Yo, what's up? It's DJ Chili coming at you with some fat C++ beats for your IDE of choice, as long as it's Microsoft Visual Studio. So we're gonna make a game. We're making a game. The name of the game is HUGS, and if that makes you uncomfortable, then maybe you're just not secure in your manliness or your womanliness. There's no girls watching this. Who am I kidding? First thing is first. Obvious statement is obvious. I want to talk a little bit about the workflow that I recommend you use when you're watching these tutorials. So every tutorial, I'm going to publish a new branch to the repository. And that branch is going to be the code for the end of that tutorial, the finished code for the end of that episode. So you could download that branch onto your local repository and run it, and you'd have the code. But I recommend that you don't do that, or at least not immediately. What you should do is create your own branch from master, which is the beginning code, and you work in that branch. You watch the videos, and then you code up yourself on your own, not just copying from the screen. And you can still load up these branches and check out how I did things afterwards, or use them sometimes when you get stuck to look at the code. But in general, you should be coding on your own. Now, the sweet thing about this workflow is, let's say you're coding along with the videos and something bad happens. Like maybe you lose your code or you get stuck. And after getting stuck, even after looking at my code, it's incompatible with yours. In either case, what it would mean is you would have to start again from the beginning, or beg someone for a copy of their code that is updated. But with the new system, let's say you've been working along with the tutorials, you finished up to lesson 3, and you want to start on lesson 4, but you lost your goddamn code. Like maybe your goddamn Western Digital fucking piece of shit hard drive exploded. Well, what you can do is you can just create a branch off of 3, which is the part that you worked up to, and just continue on from there. So you can branch off from any one of these points, creating your own branch to work with. And that, my friends, is sweet. So that's all I got to say about that. Let us talk about what we want to accomplish for this lesson. Name of the episode is map format. So I hope that gives you a bit of a clue. In the advanced series engine, the map was in a DXF file, right? DXF. I don't actually know any DMX songs, so I can't contribute to that. The DXF file contained a single polyline, and that represented the inside boundaries for the map. Inside boundaries or outside boundaries? I'm going to say the outside boundaries. You cannot stray beyond these boundaries. And that was simple, and so you just loaded the DXF into, let's get a different color, into the polyline object directly. One of the polyline constructors, I believe, has argument. It takes a string for the file name or something like that, I forget. But anyways, DXF is loaded directly into a polyline. Now, for the new engine, you can't just have one polyline for the entire thing, because you want a track, right? So you want your outside boundaries and you want your inside boundaries, which is going to necessitate at least two polylines. So now you can't just load the DXF directly into a polyline, because there's going to be 2 polylines in this DXF, the inside and the outside. So what we're going to need to do, my friends, Romans and countrymen, is gonna be We want to load this DXF into a map object from a map class, and that map object will have polylines inside of it. So we're going to have, it's going to have poly closed, now let's say out, and blah 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 in. And loading the DXF in here is going to load a polyline into out and a polyline into in. That is what we're aiming for. And also other things, not just boundaries, but there's going to be things like, let's see here. Maybe there'll be a vec2 here, and that will be the start position. So we want to be able to indicate in our file format here the start position. So we'll use, for that we can use different geometry. We can use a circle, for example. And the circle will indicate where the start position is. So when the loader, the DXF loader comes across a circle, that'll be like, oh, that is the start position, and it will load in the map information, the location of this circle, the center. That point will be loaded into a vec2, and that'll indicate the start position. So for this lesson, we're not going to do the inside and the outside. All we're going to do is we're going to create our new map format, our new map class, and we're going to have it be able to load the original boundary, the poly closed, and a start position. So it'll be able to load two things from a separate DXF file. And that's all our goal is for this lesson. So all we want to do is create our map class and have it so that it can load the boundary and the start position. And then after that, we can build on loading inside and the outside boundaries and so forth. Got to start low. Got to go baby steps here. All right. So now that we have our goal in sight, let us load up our shit. So we want to go to Team Explorer. You want to go to Connect to Team Projects. And then you want to make sure that you're connected to the HUGS project. Once you've done that, you'll see that the Solution Explorer is empty because you have to open up the solution. It might not be empty on yours because you might have already had it loaded, in which case, then, well, good for you. Good for fucking you. All right, so now you want to go to branches. That's just here in the home and branches. And just to, for completionist sake, you want to load one of these branches here. This will give you a list of the branches you can load on the remote server. You want to go origin, which means the remote server, and start position. And that will load the branch for this tutorial. That's the finished code. It doesn't mean you want to actually use that code though. Just load it up. Now, what you can do is create your own branch off of master here, and you'll call this one, let's say, local work. This will allow you to code along with the videos. That's an unpublished branch, so that doesn't appear on the remote server, and you just keep that to yourself. I, of course, don't need that because I've already done all the work. So I'm going to delete this. I'll go to start position here. I'll delete this. But you should have your work one that you're going to work in after you watch this video. Now, to start with, I'm just going to run this start position thing here and see what we come up with. So I'm going to build, and it builds, and then I'm going to run it. And we get a debug assertion failed, which is the reason why I'm recording this for the second time. So if we retry, we break, we find problem here in the is clockwise winding function. We look at our locals, we look at this, we look at vertices. This is what? Will it tell me? It won't tell me. But I believe that this is poly closed. Yeah. So this is a poly closed that was attempted, that was being attempted to be loaded. Wow, that's an awkward sentence. But the size is 0. Long story short, the answer to the problem is that this file does not exist, this map position.dxf. I didn't make it in this when I committed this code. I did not make this file yet, and so it's not part of the commit. It's not part of the branch. So we need to make this file. I guess my reasoning for that was that I wanted to make it on the tutorial video, so I don't know. That was a while back. You can see when I published these branches, or when I finished them, you can see here, this was April 6th, so it's a few weeks ago already. Out of my mind for sure. What am I looking for? Okay, so what I want to do is open up the original map file, and I want to modify it. So we'll go to Solution, we'll open the folder, then we'll go into Engine here. We'll find map.dxf. And you guys will want to download LibreCAD if you haven't already done that, so you can follow along with all the fun. But basically, I want to add a circle to here to indicate the start position, and circle by center and point. So I'll just add a circle around here somewhere. Say here. Sure. And then I want to file, save, and HUGS, and engine, and map pose. There we go. Thank you very much for cooperating. Not really, though. Not really cooperating at all, did you? Now we're going to run it, and it works. And we notice that we started in the position where we put the circle. Right, if I were to put the circle here, circles, put a circle right here. File, save. Get rid of that. Get rid of that. Start without debugging. Now we start here. So that means our program is working as we expect. Now comes the fun part, to figure out how we get to that point. So for my workflow here, for giving you guys the tutorials, I got some sweet ass stuff prepared. So what I'm gonna do is, let's see here, go to Team Explorer. I'm going to view the history of this branch, and here we have the commits, which are basically the saves that I've done in this branch since I've started. So I did one commit here, which was, I think when I created the thing on GitHub, this was the first commit. Or maybe not, I don't know. Anyways, first commit when I created the repository. Second commit when I had the code all ready for the starting point. And then the third commit was after I branched to start position and I finished all that code. So I'm going to check history, not. Okay, yeah. So we go to, we double click this. And that'll give us the details of the commit, which will give us a list of the files which have changed. And then for each of these files, I can click on it and compare with previous. And that will let me see what I changed compared to the previous commit. And that will allow me to explain to you guys what I did without, missing any areas or anything. And it will also, by doing so, allow me to avoid typing everything in front of you guys, which wastes a lot of time and generally results in a lot of expletives. So, what should I look at first? I guess I could look at polyclosed first. What do we change in here? So compare with previous. All right, so what do we do here? So I added basically a new constructor here. And that allows me to copy construct. Right, because we have the R value reference here. So this allowed me to copy construct, or not copy construct, move construct from a vector of vectors, right? A vector of points, basically the polyline, and copy that into the polyclosed object. Right, because normally what we had up until now is we had file name and then we used the loader to load. But now we're gonna just give it the raw data in a vector. All right, so that's pretty simple. And you can see here, that's the only change that we made because there's nothing else in this area here. So let's look at, what did I do in triangle strip? I changed. Oh, I just, this constructor was commented out from, this code is from Albino Papa, and he had commented this out for some reason. I just reinstated it, but I don't think I used this. I just did that because I figured, hey, more constructors, better, right? What else we got here? Ship. All right, what did I do in ship? Oh, I changed this string loader to use W string. Right. Yeah. So here, I had hard coded the file name into the constructor. So basically, this argument here was just being ignored. So I made it so that I could change the argument here, and I also changed it to a wide string just to make it, I don't know, match the rest of the code, I guess. I don't know. All right, so that's what I did there. Nothing big in these two files. Nothing too huge in polyclosed. So all the action is happening in map, which is the newly added file. Because map, it existed in the previous version, but it barely had anything, I guess. Triangle strip boundaries, models, wall width. Yeah, map barely had any stuff in it. It was basically just a pass through into the polyline, polyclosed, and it stored the boundaries as a triangle strip, or the model as a triangle strip, the boundaries as a polyclosed. So now we're going to add a lot more stuff into here, because now the loading is not going to happen in the polyclosed. The loading is going to happen in the map. So let's just maximize this thing here. So a lot of this stuff is just, first of all, what I did was I copy and pasted from polyclosed the loader here. I just basically copied this loader code. Oh shit, that was bad. Let's go back here. I copied that code into here. And yeah, so add vertex is just going to, so the loader here has a vector for vertices, and it also has a vector for the start position. And whenever you get a vertex data, you push that into the vertices. And whenever you get a circle, you use the position of the circle as the start position. What else we got here? This is the move constructor that we use with the loader to move the data out of the loader. And here is a function to get the start position, which is used later to get that information to figure out where the ship starts. So, yeah, that's about it, I think. I mean, not much has changed. I just added this add circle function in here. Overriding it, right, virtually. And the rest is mostly the same. So the loader loads that data into the vector and this vector. And then, so we create the loader here. Then, what is this? P boundaries. Ah, right. Right. I guess I got to talk about this now, which is kind of confusing. But if you look at the original code, let me just bring it out here. The original code, the poly closed and the triangle strip objects are embedded in the map. And if you embed objects, you know that you have to initialize them in an initializer list like this. And that works because we can initialize the boundaries with the file name. And then we can initialize the model with the data in the boundaries. However, we can't do that here. Now, can you figure out why without me telling you? That's the question. Well, I'm going to tell you right now, so if you haven't already figured it out, you're too slow. The reason is that we need to get multiple items of information out of the loader. Previously, all we needed to get out was the vector of vertices. But now we have to get out the vector vertices and the start position. So we can't just pass... we can't just create a... we can't just pass the file name into here, or we can't create a loader and pass that into here, because the loader has to live long enough to also fill in the information of the start position. So that means that we can't initialize our boundaries and our model in the initializer list. So we have to initialize it in the body here. But that means we can't embed it. We're not allowed to embed it if we can't initialize it in the initializer list. So what I've done is I've used pointers. We use pointers and we dynamically allocate the memory for the boundaries and the model. Now we could just use a standard pointer, and then in the constructor we use new, and in the destructor we use delete. But the smart way to do the same thing is to use a unique pointer. It's a smart pointer. And when you use a unique pointer, then it's embedding the unique pointer object, and when the map is destroyed, the unique pointer will automatically deallocate the memory that it's pointing to. So it's a lot safer. It's easier. That's why it's called a smart pointer. So we create the loader. Then we initialize the smart pointer for boundaries with the loader, the information in there. Then we initialize the model with the data which is in P boundaries. And then we initialize the start position with the start position in the loader. The rest of the stuff is basically more or less the same, right? Here we have, for get drawable, we return P model, get drawable. Handle collision, we use boundaries for the collision. And get start position, we use start position that's in here. All right, and then in the game, what do we got here? In the game.h, we add the map. That's weird. I just moved the map here. Oh yeah, because the map has to be initialized before the ship, because the map contains the start position of the ship. So I had to move the, remember, in an initializer list of embedded objects, the objects are initialized in the order in which they appear here. So you want the map to be initialized before the ship because it contains information about where the ship should start. And in game.cpp, here we change, I also changed the order in here, although it doesn't actually matter. It's just easier. It's not misleading if you put it in the right order here. So I put the map first. I changed it from map to map position. And for the ship, I changed it to USS Turgidity, because now this argument is actually being used. And for the position, I didn't, here the position is just hard-coded, but here it's loaded from the, it's queried from the map object. And that's it. That is how babies are made. And when you build it and you run it, you get this. That's it. Super simple. You might ask me, well, Chili, how did you know that this function, the name of the function you needed to overload was add circle? And I didn't know. All I did was I went anywhere inside of the loader. I just went this. Wait. Cocksucker. Okay, you can die now. Where is map? Here it is. So anywhere inside of loader, I just went this pointer to, and I just looked through the list of stuff in here. And you see all the adds here, and I just saw add circle. And it takes DL underscore circle data and whatever. So then I said, okay. And I created the member function to overload that or override it, and with the proper argument here. And then to figure out where, like what I needed to get the center point of the circle, I just went data dot, and I looked at what data I had. I got the radius here, and I got three coordinates, or the three ordinates for the coordinates. And that's that. You don't even have to look up the documentation. You can just use IntelliSense to figure out what the names of the functions are that you want. If you already have an idea of what you're looking for, it's pretty easy, usually, if things are named properly or in a logical manner. And so, yeah, that's what I did. I'm just going to undo that because I didn't actually do anything. And yeah, that's it. I honestly can't think of anything else, any other changes. It's mostly just all in this map here. So, yeah, next, I guess the most complicated thing, or the takeaway point here, is smart pointers, which you've already used before, right? In the loader here, we use the smart pointer to dynamically allocate the memory for this DXF thing. Because when we created it on the stack, it created a stack overflow. Because for some reason, it's just motherfucking huge. So we dynamically allocated that and then used it to load the data into the loader. So we've used this before. You have seen this, but here's more of it, I guess. I use smart pointers whenever I can because they have very little overhead and they make it less likely that you're going to shoot yourself in the foot by forgetting to deallocate memory. So they can make this data behave more like it's embedded even though it's not embedded. Because again, I can't embed it because I need the loader to live. I need to create the loader object as a named variable so it can live and, you know, pass its data on to multiple components of the map. There. I managed to navigate my way through that English sentence somehow. Next lesson, because this one's basically over, we are going to figure out how to load the inside and the outside boundaries which is going to be a little more complicated than you might think. Or at least it was more complicated than I thought, but very doable nonetheless. So that's the video. I hope you enjoyed it. If you did, click the like button. It helps a lot. And I will see you guys next lesson. Ta-ta.